Hey everybody, welcome to our first video lecture. We're going to have one of these at the beginning of every week, usually on Mondays, and there should be a total of 7 of them by the time we're done with these. Hopefully everybody's found everything with the way we have Google Classroom set up, and again, if you have any questions, feel free to email me. But you should have downloaded the guided notes for this, and you're going to fill them out as you go along. If you took your science binder home, you might already have these notes filled out. But this is what we ended on, so I want to make sure to review this before we get started. So make sure that you have these written down somewhere if you don't already have them. So without further ado, let's go ahead and get started. So first off, we are talking about states of matter. Your I can statement is I can explain how solids, liquids, and gases move on a molecular level. So we are going to be looking at states of matter to start. So first off, matter is anything that takes up space and has mass. Those are two very important things. So they have to take up space, so they have to be somewhere. You have to be able to, they have to be tangible, and they have to have some sort of mass to them. They have to be made up of atoms. In this picture, you see a boulder, guy holding it up. He's very strong, almost as strong as I am. We have a snapping turtle. He looks very happy. We have water vapor given off by a nuclear facility's cooling towers, and you have water. So what do all of these things have in common? You guessed it, they're all made up of matter. Woohoo! So our states of matter we are going to talk about. Now there are 5 of them, but we are going to talk about 3. The first is a solid, and a solid is matter with a definite shape and definite volume. That means a solid has its own shape and it has its own size. It doesn't depend on anything else around it to give it its size and shape. So our first example would be rocks. Yeah, any rock you find out outside is going to be a solid, right? It's going to have its own size and it's going to have its own shape. Another example would be something like ice. Over here you have a frozen waterfall. Here you have a glacier. Down here you have some pretty ice cubes. Yay. So when we talk about solids, we are going to talk about 2 different types of solids. The first one is going to be what we call crystalline. Crystalline solids are solids that have their particles arranged in a repeating 3D pattern called a crystal. An example of this would be salt. So up here is like table salt, down here is if you zoom in a little bit, and this is all the way zoomed in on a microscopic level. You can actually see how they form a cubic crystal. And up here in the right is a picture of a salt mine. I believe this is in Germany. Or salt or sodium chloride. Another example of crystalline solid would be a diamond. Diamond is just crystallized carbon. Now, not only do we have crystalline solids, but we can still have solids that form together, but their particles are just kind of blob together. We call those amorphous solids, and those are solids that have their particles arranged randomly. If you think back to our prefix suffix root words, a means not, morph means shape or form, so that means it literally has no shape or form of its own. So an example of that would be something along the lines of glass, where you have to melt down quartz and you get this blob of hot molten glass, and then you have to form it into a shape. Another example would be something like plastic, where you have to, again, melt it down and press it into a shape. Our second phase of matter would be a liquid. And a liquid is matter that has a definite volume but no definite shape. Like, we know how much is there, but it has to be in some sort of container. And the best example right off the bat would be water. Right? We can have water in the shape of a water bottle. We can have it in the shape of the pipes in your house. But water doesn't have its own shape. It has to take the shape of a container. Milk would be an example of a liquid. A liquid does not have its own form, but again, it takes the form of the container it's in. Now, when we are talking about liquids, there are some properties of liquids that I would like to cover. The first property we're going to talk about today is viscosity. So viscosity is the amount of resistance to flow a liquid has, or in essence, it's how thick a liquid is. So if we have a thicker liquid, we say it has a very high viscosity, and that would be an example of something like honey, or something like toothpaste. So those are very highly viscous liquids. Now on the opposite end of that, we have what we call a low viscosity, which means it's flowing very well. An example of that would be something like isopropyl rubbing alcohol, flows very well, or water. Water has a very low viscosity. Surface tension is the uneven force that acts on the particles of the surface of liquid. We looked at this a little bit at the beginning of the year when we did the drops of water on a Penny Lab. We're not going to get into that too much. Our third phase of matter is going to be a gas. A gas is matter that does not have a definite shape or volume. So not only does it not take up a certain amount of space, it also doesn't have its own shape. So you get things like water vapor, should be an example of a gas, or carbon dioxide. So like a liquid, a gas doesn't have its own form. It's going to be taking the shape or the form of the container it's in. We also use the term a vapor. A vapor is a liquid or a solid that exists in a gas state. Okay. And an example of that would be something like clouds that are water vapor. Okay, awesome. So I know I went through that kind of fast. This video is around 7 minutes, 7.5 minutes long. So what I want you to do, if I went through that too fast, the cool thing about this being on YouTube now is you can go back through, you can pause the video, and you can fill in the notes as you need to. Okay, and again, if you guys have any questions, please email me. Let me know what I can do to help. Yeah, other than that, I hope everybody is staying home and staying safe. And I hope to see you guys sooner than later.